When Gravity Paramotors was founded over 8 years ago, we had two real goals in mind. Build a product in the USA that was worth flying, and the second part being build an affordable paramotor that helps introduce more people to the spirit of aviation. With the Gravity Paramotors Defiant, we feel that we've definitely achieved that. If not, very close to the most affordable paramotor with the quality that you deserve. You're going to receive 3 boxes in your Gravity Paramotors Defiant shipment. One's your brand new engine, your Viterazzi of your choice. A tank box with many of the same basic components and features that typically don't change, such as your spokes and your fuel tank. Your third box, that's your custom box. That's going to be where your custom harness that you chose is and your customizable options that truly allows you to make the Gravity Paramotors a unique flying machine to fit your style. We're going to be taking you through the entire build guide of the Gravity Paramotors Defiant. Do keep in mind, this is only a build guide. It is up to you to make sure that your aircraft is safe to fly. You're going to hear me reference countless times about using Loctite, as this is aviation and you don't want to have anything come loose. Your first and foremost contact of support needs to be your Gravity Paramotors dealer. Your dealer is there to help support you through the build process, and if this build guide's a little overwhelming to you, you can also opt to have your dealer build your paramotor for you for a slight additional fee. It's highly recommended for those who have no build experience or mounting experience of paramotors previously. Please do keep in mind, we're just 3 guys trying to make this all happen with a paramotor made from the USA, is that our first priority is getting the paramotors and products to the customers, to you. So with that in mind, please understand that we cannot offer factory support to each and every end user, and your point of contact has to be your dealer. While we love to hear from you, and we'll take whatever time we have extra at the end of each day, we cannot be the first support. That's why we're trying to produce these up-to-date build guides, and your primary contact needs to be your dealer. Let's go ahead and dive right in to show you how to build a paramotor. As you guys can see here, we have over 150 components that go into building your Gravity Paramotors Defiant. But don't worry about it, we're going to take you through each part step by step. Next segment we're going to be going into is the pre-sub assemblies. And that's going to be things like the netting tensioner, as well as things like the spoke to hoop holder adapters. A lot of the things that are going to be a whole lot easier to do on the bench, rather than when you do the final assembly to the fuel tank monocoque structure. So stay tuned, we're going to show you how to take this pile of parts and turn it into your next flying machine. Not that anything we're going to be doing in today's build is rocket science. There's certainly a few parts that make it a little bit more frustrating, like this small multi-piece netting tensioner. We have all kinds of small parts involved, especially including these really small springs. They like to shoot across the room, so we go ahead and include you 2 of them, just so you get a gimme. So we're going to go ahead and dive into what it takes to put together the tensioner. So the tensioner arm goes from the single side into the double side. And as it just goes into the second wall, you're going to be inserting the gear. And the gear you have to pay close attention to, because as you put it up against the lever arm, one way will catch, one way won't. And that is the way that you're going to want to install that gear. And the lever goes very close to that hole here. So as you slide it in, it is slotted, so it does help to use an Allen wrench to line up with the square slotted of the tensioner arm. And sometimes it makes you feel like you're playing with Legos back in the day. Now that you have the gear over the tensioner handle and protruding out the other side, you'll take this little small cap, place it over the end until it drops onto the same cut piece that the gear did. And you're going to take your M4x12 flathead, and that's going to secure the cap on. You are going to want to apply, again in that situation, purple Loctite. With Loctite, it needs to be snug, but not overly tight. Next, we get to play with this wonderful spring. So we're gonna go ahead and set our gear lever handle in place. We're gonna pre-apply Loctite to the M3x16 socket cap head screw. You're gonna place it into position and through the gear handle. You're gonna take your wonderful fly across the room spring, help set a set of channel locks. You're gonna slide it right in between the bottom slot that you can see from the end. And you're gonna try and work the screw all the way through the spring. Once you're confident it's past the spring, you can release the pliers and go ahead and finish tightening. On this one, you will want to be sure it is designed to only be slightly positively anchored, is that if it's tightened too much, it'll actually induce tension onto the gear handle and the gear and prevent the tensioner from releasing. So apply only minimal tightening pressure there. Then we're going to go ahead and clean up the springs. So now we're going to do this lovely little task of trimming the spring. So on the flat edge of where it mates to the fuel tank, you want to take a pair of cutters and be sure that you cut it just ever so slightly subsurface so that your finger won't catch on it, won't intrude anything when installing it to the fuel tank. For the little spring here that doesn't quite follow the curvature of the handle, you will need to very carefully work a pair of needle nose into the spring before the gear handle, and you pull and bend it back at it. And you want it to fall in line with it can be a little bit off, and you can sometimes get an extra rebend to be a little bit more aesthetically pleasing where it falls. And it'll take several to get right so that it falls right in line with here. And again, you want to trim it just a little bit subsurface so that your finger will never catch on it while using it. So at that, we can go ahead and throw this part aside and it's ready to install on the tank. Now that we did one of the more difficult pieces like the netting tensioner, now we're going to go ahead and take it step into something a little easier. And that is pre-assembling the small micro detents for the spoke holders. So you do want to apply Loctite to them. However, do be sure not to get any Loctite on or near the ball detent, as that potentially can cause you issues down the line. You can go ahead and hand start it. And it's going to be mostly threaded all the way. In order to test fit, you will need one of your spokes. You want to insert the spokes, tighten the spring detent down all the way. Then after you make snug contact, you're going to want to back it out almost a quarter turn or less. And then make sure that your spoke still comes out, but has a very positive locking action. And if it doesn't have positive locking action, thread it all the way back in, back it off quarter turn or less, check fitment. That's good fitment. Now all we want to do is repeat the same for the other four. So next, we have the spoke to the hoop holder attachments. Here, you do have two halves that you need to identify. You can look down inside them and see that one has a stair step and one does not. With that stair step, it's going to take one of the M6 inserts, and the bolts you're going to be using today are the M6x30 button heads. From there, we need to try and drop the insert down inside the spoke holder. A larger Allen wrench does assist with pressing the insert all the way into the hoop holder. You'll grab one of your spokes and you'll attach one side and then the other, the one that has and doesn't have the insert. From there, you will want to make sure that they are directional. So you make sure that they curve inwards toward the center of the paramotor, not outward. You're going to take your M6x30, apply a fair amount of Loctite, just like you've done on the entire rest of the build. And you're going to thread it down into the spoke holder. Sometimes if you apply too much pressure, you will push the insert back out the other side with the bolt, and you can assist it with that same large Allen wrench that you used to hold it in place in the first place. And you are going to want to apply a fair amount of considerable pressure to make sure that both the insert is seated all the way inside to the spoke holder and that it's completely tight. From there, you can confirm that the angle is curving inwards towards the paramotor, or what will be the paramotor. And from there, you're just going to go ahead and repeat 5 more times, and we're moving on to the next step. We have the pulley for the rope starter. In your bag of parts, you'll have this itty bitty small cylinder threaded piece, and the bolt we'll be using again is the M5x20 socket. Place it through the top of the upper hole, and you will want to apply again your purple Loctite, and then that's going to thread on the end on the upper only. Tighten down. For the lower hole, that'll take the bike cam clamp, and that is what attaches to your spoke. In fact, let's go ahead and attach it to a spoke again. So with here on every spoke, you'll see a small drilled out no thread hole and an even smaller threaded hole. So the piece that we attach to the pulley slides in midway of the spoke, line up with that threaded hole, and you'll go ahead and thread in the cam. The first time, do be aware that with tolerances and anodizing, it is going to take a little bit of effort to go ahead and thread into the spoke. Subsequent times will be much easier. Once you get it down to within about 1/8 of an inch, 1/16 of an inch of the pulley, and you can check along the way to see if the cam folds tight up against the pulley. It's ready to install on the paramotor. To set your paramotor up to be able to stand up, you're going to take the piece of tubing that doesn't have any rivets along its radius. That's for its lower piece of tubing where the legs go. Take the legs, match it up to the radius of the tubing, slide it on the end. You're going to want to slide it down approximately 1/3 down the tubing. Then the other side. And you may meet resistance while it meets onto the tubing. And if it is tight, you can go ahead and take a flat blade screwdriver, widen it just a touch. Tolerances are a bit tight. Slide it down to both sides approximately 1/3 in from the radius of the tubing. You will be using an M5x20 socket head screw, and you're going to apply Loctite to both. You're only going to want to tighten to a very minimal amount, as you'll be doing the final adjustments once your paramotor's up and standing on these feet. And you will want the least amount of clearance from the tube to the ground to give it the widest stance and most stable that it can take. The closer they are together, the more unstable your paramotor will be. The wider, the more stable. At this point in the build, now we're able to actually play with the fuel tank. So this revolutionary design from Gravity Paramotors for the Defiant is a monocoque fuel structure that hasn't been seen anywhere before in the industry, where this is actually a structural component to the frame, where traditionally the tanks would only be used as a bolt-on accessory or even potentially a curved guideline for the body, but still retains a metal structure. With this, the fuel tank actually becomes structural for both the spokes, the hoop, the harness, and everything in between. With this monocoque design, it also can help save you money in the long term. We get often questioned about how strong this tank is, and the tank doesn't begin to break, fracture, until you would have taken such a hard impact you would have bent a normal tubular frame tower structure. with the average tower structure ranging from around $1,500 and up to replace, with the fuel tank being able to replace for under $700. So with that, you're able to have a more economical paramotor, carry a larger capacity of fuel, and if you do happen to have one of those accidents that do some damage, you're going to be back in the air for less money, as well as at a quicker time pace, because everything's right here in the USA. We're going to go ahead and begin with the very bottom of that fuel tank. We're going to first install the skid plates. Going to be 2 large plastic skid plates here, and it's going to take 6 M8 by 12 flatheads. And as always, again, as the entire rest of the build, we are going to go ahead and apply Loctite. And when you're dealing with so many screw holes, it is advisable to only start each one, and after you finish the 3, you come back and tighten them up to ensure that proper alignment on all 3. Moving up the tank, going to be installing the netting tensioner. At this point, you do want to be sure to do a final function check and ensure that all parts move freely before installing. And do be sure to get all 4 of your M6 by 12 flatheads started before tightening them down all the way. And these are flatheads as well. Do keep in mind throughout the entire build, anytime you're tightening any of the bolts into the monocoque fuel tank inserts, is that these are just inserts into plastic. You don't need to go Superman on them. It's snug enough to keep the part from leaving your aircraft with Loctite. So do be careful on it. Try not to over tighten. At this stage of the build, we're going to go ahead and install only 3 of our 5 total spoke holders. We're not going to install these lower 2, as those will get installed on the engine adapter plate coming in a moment. But for the upper 3, we're going to be using custom, made by us, M8 by 50 to 55, depending on our production run, of aluminum bolts made by Gravity Paramotors. So we're going to take the spoke holder that we made earlier. We're going to make sure that our detent's still in place. That's going to go to the outside or back side of the build. Simply hold in place with the front capture plate. Now, the little bit of drawback, those aluminum bolts are dramatically lighter than their steel counterpart. However, aluminum on aluminum is extremely easy to cross thread, so do be sure to try and make sure you should be able to thread it all the way in, down to the base plate with minimal finger tension on the bolt. If you have to apply an Allen wrench at this point, you're probably cross-threading it. Do be sure to go ahead and back it out and try again. If for some reason you do happen to cross-thread it, a fixture that you can use is use one of the steel bolts, such as for the upper harness attachments. Drive the bolt in back the other way to clean up the threads going back in, and pay a little bit closer attention to make sure that you don't cross-thread that fancy lightweight aluminum bolt. We're going to go ahead and do that for all 3. Be sure to apply Loctite, and in a moment we'll be addressing the lower 2 on the engine installation. To attach the harness ground supporting straps and limiting straps, it's going to be 4 M6 by 14 button heads. Loctite as always. For the most aesthetically pleasing build, you will notice that there's finish mount on this side, a little bit less finished on this side. So we do want to have our finished product looking the best that it possibly can. And you'll also notice the groove molded into the tank basically gives you the direction that it should be attached. You will, on final tightening, want to make sure to hold the strap in place to prevent it rotating with the bolt. And we'll do this on both the lower and the upper, and then repeat on the other side. Now we're going to be moving on to some of the fuel system components. First, we're going to start off with the filler net cap. You're going to have an O-ring, be sure to place that on the underside with the groove of the filler neck. We're going to be using 4 M5 by 10 flatheads. And if you guys weren't tired of hearing it enough, do not forget the Loctite. So on this part especially, you want to ensure that the O-ring stays in place. So you're going to want to keep some tension on the filler neck cap. You can also take a peek as you do your second one. Peek underneath to make sure that the O-ring is still in place. You only want to start just a couple of threads on all 4 to ensure that they're all lined up and holds that O-ring in the proper position. Once the 4th one's in place, you can bring them all down just to with minimal pressure. And you can watch the sides and see that it's pulling down the plate in an even fashion as to not pinch off the O-ring. Jump back in the traditional star, jumping back from side to side. Before doing your final check on all 4. At this point, we can go ahead and install the fuel cap with the tether. Push the tether all the way inside. Now we can move on to the fuel line. You have 2 sets of length of lines. One is a pre-measured to reach the bottom of your fuel tank. Do not alter its length in any way. And then you have a short one, and that is to help connect from the fuel tank to the primer bulb and primer bulb to the engine. So we're going to take that, we're going to set the short length and the primer bulb aside. That's going to be used once the engine's installed. For the other length, we do have a Porex filter included in the kit. To assist with that fuel line, you can take a smooth pair of needle nose. You can stretch out the cable for a few seconds to make it easier to put the fittings on. You do want to ensure it makes complete contact all the way up to the base of the Porex filter. That's going to go down in the fuel tank first. When you set your paramotor up, you will want to ensure that your Porex filter made it all the way to the bottom of the fuel tank. As you get it close to the end, you're going to take the rubber grommet with the male end down towards the fuel tank. Place it down near the base. We'll go ahead and install this end on the fuel line with the same trick as used before. Pair of needle nose, stretching it out. This one's a little bit longer, so it may take 2 or 3 positions. Applying a slight amount of heat can also assist this as well, or a fuel lubricant that you may have at your disposal. You're going to work that all the way up to its next flange. From here, the male part that goes into the fuel tank, it's difficult to show you, but you'll start 1/2 of it, and you may need to use something not sharp like a smaller Allen wrench to assist the smaller final pieces to protrude into the tank. You can apply pressure and twist. You want this flange to meet all the way to the fuel tank body. Once that's achieved, you'll push the 90-degree insert down to it. At this point, it will take a fair amount of pressure, and you do want the square head to mat all the way up to the rubber grommet. It can take substantial force. If you use any additional leverage devices such as a hammer, be sure to protect the fitting with a block of wood. Now we're moving on to prepping your brand new Viterazzi. So we have a few things to do. We have a bit more parts than we've had in all the previous steps. We're going to go ahead and take you through those now. We have the engine adapter bracket. We have to identify what direction it goes. So if you look at the large point tip, the The radius edge, it follows the knuckled exhaust. We're going to lay that on the engine as it would go to get a layout. We have the aluminum insert piece that goes into the fuel tank. One side's a single M8, the other side is dual M6. That's going to set on the plate as such. We're going to remove that to add our first two bolts that are M6 by 16 button head. In the future, you may need to remove these. Purple Loctite is more than sufficient. We also have 8mm carbon spacers that will go between the engine mounts as well as the engine adapter plate. These are required, do not add or subtract. We have this for specific spacing of prop clearance. The bolts that we're going to use to go into the lower engine mounts are M8 by 18 button heads. These are critical engine bolts. We do recommend blue Loctite. From here, we're going to use the other two 8mm carbon spacers for the upper two holes. And then we're going to be using an M8 by 16 with a fender washer built in. It's going to come in from the backside to away from the engine. We're going to screw on the spoke adapter block, and we're going to identify it by that spring detent is going to face, again, away from the engine. So, as mistakes happen for anyone, 3 steps after we originally shot this, we noticed as we're trying to build this on camera and upside down. Told you wrong. So the proper way to install the spoke block is same 8mm spacers that must be installed, that fender M8 size, except instead of the detent, originally I told you to go the detent up, it's actually detent towards the motor. So it's going to be M8 bolt from the back, detent, same where that we applied to hold the spoke in place, towards your motor at the same 45-degree angle. So we're going to loosely attach those on both sides with still a little bit of play. Already went ahead and pre-applied purple Loctite. And we're going to see if we can get it right this time so we can continue on with the build and show you how to mount it to the fuel tank. As we move on to installing the throttle, please understand that there's many different throttles available on the market today. Gravity Paramotors for the installation videos will be supporting the Viterazzi V throttle only. Outside of the Viterazzi V throttle, you'll want to either contact your dealer and or have experience with installing the other throttles as well as the tools needed and parts needed. With the Viterazzi V throttle, our first step is going to be attaching the throttle to the adapter bracket. We've removed the air box simply to get the camera shot. It can and very easily and commonly is done without the air box removed. First, you're going to remove the nut and the small parts associated with the end of the throttle, as we've already have laid out here. We're going to route the throttle underneath this exhaust bracket that lists that you have an MY20 engine. We're going to pull the cable and we're going to feed it through that throttle bracket here. Gonna press all the threads through. We're gonna fish the nylon lock nut down onto the cable, making sure that the nylon portion is the furthest most out. And we're gonna go ahead and start that by hand as much as possible. You're gonna need 2 10mm wrenches for this job. Try and give you guys a proper angle so that you can still see what's going on here. Put one holding the base of the throttle, and you're just going to work this process down. And with that process taking more than a minute, we went ahead and spared you the agony of watching that. Now that we have the jam nut or the nylon lock nut tight up against the adapter bracket for the carburetor, we're going to go ahead and work on the cable as well as attaching the 3 small parts to go to the throttle. The first of those 3 small pieces is going to be one of the cable stops. We're going to slide it onto the cable first. Zip it all the way down. We're going to take the small brass insert as that. We're going to use put the pointy end or the smaller diameter end on first, and then the second cable stop. Quick tip to keep your parts from falling on the floor: go ahead and wrap the excess cable around something to prohibit those from falling off. We're going to place on one side of this small circular piece, there's just a slot, and on the other side there's a drilled out hole slot. That small brass insert is going to go on the hole slot with then the other cable stop chasing it. Your throttle will need, for the addendum Viterazzi install, is going to need some form of securing method on the trigger itself. You do want to secure it at full throttle. At this point, this achieves your throttle achieving full throttle at the same time your throttle maxes out. If you achieve full throttle on the carburetor before your throttle maxes out, your hand can obviously overcome this small piece of plastic, and that can tend to be one of the reasons leads to this plastic part being broken. So in order to match the throttle that we have set up, we're going to want to put the throttle to full throttle as well before tightening up the outer cable stop. Make sure that your brass piece is seated all the way in. Pull your throttle cable taut, and then you're going to tighten the cable stop. And this is a little easier when you're not trying to leave it open for the video camera. Make sure that it does achieve full throttle travel. At this point, I'll have to close off shot for just a moment while I pull it tight just a little bit more. Now you can release your throttle cable. Have a little bit more wiggle room to ensure that the outer cable stop is tight. You want to ensure that you achieve full throttle all the way to the stop on the carburetor at approximately the same time that you achieve full throttle on your plastic throttle. A minute amount of extra play is okay, just not anything excessive. Now we'll want to pull up the other throttle stop to the opposite end of that small cylinder attachment point. And again, unfortunately, I will have to block your view just to go ahead and tighten that piece. So you can pull the excess cable off to one way, make sure that this gap here is closed, and then tighten the set screw. What this now stops your throttle from doing is having enough play between here and the cylinder that when their throttle goes loose, for it to jump off of the throttle. An alternative method of install is apply an additional tension spring between where you attached it from the carburetor to throttle adapter bracket to that cylinder, is one method. It will increase your throttle resistance, but now you have a set screw on either side. It allows your throttle to go to full throttle while reaching full throttle on your carburetor without putting undue stress on your throttle. To deal with all of the excess cable, we're going to go ahead and loosely trim it just beyond the redrive. This is to make it a little easier to deal with. We're going to take a drill. We're going to pay attention to the threads and how this cable is wound. In this case, it is wound counterclockwise. We're going to go ahead and chuck the drill around the cable. We're going to take a pair of locking vice grips, and we want to pick our point to just prior to the redrive. That way, no part of the throttle cable could actually reach the redrive of what we have left. And for those of you that have spoken to Bill, as he calls it, the creme brulee torch. And we're going to heat up the cable, ensuring that our drill's in counterclockwise rotation. We're going to heat up the cable right next to the vice grip, and we're going to slowly begin to twist until it snaps. This now gives us a wire weld connection that won't fray, and in the event of needing to remove, change, any sort of maintenance to our throttle, keep that in from fraying. Next up, we're going to attach the kill switch. The ground connection is actually embedded into what we tightened down with those M10s before. Now all we have to make is the connection to the ignition coil here. Make sure that you have routing of what position you'd like it to go. We've already pulled it through the engine adapter bracket as it flowed best. The cleanest routing right to this itty bitty point right here on the ignition coil. Make sure that we're happy with where it would be. Pull it back out. We're going to trim it. We're going to go ahead and strip it. Depending on your strippers, it may take a couple different tries. It is a small, very small wire. In our case, we're going to go ahead and fold it over, double it up. We have the blue connection, spade connection that we sent with the paramotor. Make sure that you can see a little bit of wire sticking out beyond. You can take a pair of pliers, vice grips if you don't have a nice set of crimpers. If you do have a nice set of crimpers, be sure to match red to red, blue to blue, yellow to yellow, crimping 101. Make sure it seats all the way. Go ahead and grab the wire, give it a nice firm tug. Make sure that she's firmly crimped. If she's not, now's the time to fix it, not once you're in flight. The spade connector, the male spade connector on the ignition coil here is thicker than the average spade connector that this is designed to go onto, so it is going to be tight. You can attempt to put it on by hand, is one method, and it will take a very significant amount of pressure and may take a little bit of back and forth action. An alternative method is take a small flat blade screwdriver and just barely open up the tips where it starts, is another method. If you're still having difficulty and you only want to be pushing near the base of the spade connector, an alternative method is use a pair of small pliers to reach in, apply just a slight amount of force as you again do the slight movements to ensure that the spade connection comes all the way down and comes close to touching the epoxy inside that spade connection. You want to be able to apply light pressure and have zero movement. If this moves, you need to readdress your connection, as this is your ability to kill the motor, which becomes a very serious safety feature. And you need to make sure that's right before you ever take this aircraft into the air. Now comes the wonderful time when we get to mount the brand new Viterazzi to the new Defiant. So we're going to grab our fuel tank. As said before, the spoke block adapters approximately 45 degrees. Line up the 3 contact points. A little awkward from this angle, but adjust the rotation of the spoke blocks till it drops down into position. With here, we're going to first use the lower attachment bolt, which is an M8 by 50 with the center mount for the plastic adapter. And if you still aren't done with me harping on you, don't forget that Loctite. We're going to go ahead and just loosely install that one to help us pin it in place. We're going to use those other 2 custom aluminum M8 by 50 to 55s. The front plates. And you guessed it, don't forget the Loctite. Those go down into the 2 lowers. At this point, you'll want to be sure to take some of the stress off the fuel tank, and just with an ever so light touch, do make sure that you're not cross-threading those custom aluminum bolts. While they have the strength for the position when threaded, aluminum on aluminum does have a high probability of cross-threading. At this point, the tank's self-sustaining. We have custom M8 by 85s, and for those of you who are familiar with hardware, can't really get M8 by 85s. It jumps up to M8 by 90s. They're cut down here. The 2 plastic inserts that are offset, as you look at the fuel tank, they're offset to your right, and you can read the GP on the plastic. Again, at this point, Loctite, do recommend the blue. Drop it down into the face of the tank. We're going to grab those 2 remaining custom M8 spacers. We're going to slide it in between the engine mount and the back plate. Push the tank down onto the engine mounts, and you are going through the tank, the back brace, the carbon M8 spacer, and then you're also trying to get the bolt started past the safety strap that comes on the upper Viterazzi mounts. And in some cases, we'll just take many twists, shuffling the tank around, shuffling the bolt around in order to get it past that safety strap. So at this point, all 5 of our contact points are tightened, or at least snug. Now we want to go through and do final tightening. And again, guys, do remember the design of this paramotor. It is not designed to be cranked down like your Superman. You want to bring everything down to a firm. You can take a standard Allen wrench or T-handles, and you apply firm yet not overly tight. If you start to feel the tank give, you're obviously trying to put a little bit too much force on it. Now we will return with you on the next shot with tightening up the backside to that spoke to the lower engine adapter brace. With the tank now flipped over, we're going to be sure to tighten up those M8s that go from the engine adapter bracket down to the spoke holders. We're going to tighten up one side and then repeat for the other. Finally, we get to throw some spokes in so we can stand this beautiful machine up. Grab each spoke of the lower 2 out of the 5. Attach it to the 2 lower spoke blocks that tied in the lower engine support. Tubing with the aerofoil shape forward as the paramotor flies. Do keep in mind these plastic pieces, and well as the tubing, both the aluminum and the carbon fiber, tolerances are pretty tight and some of them can be snug the first couple times going in and out. From here, we're going to go ahead and set the paramotor up and adjust its feet. So here you go ahead and do what's aesthetically pleasing for upright on the fuel tank, and we want to shoot for as small a gap as possible is down here. And in this case, everything's already set up nice for the split. The paramotor's vertical, and our clearance between the tubing and the ground is minimal. We'll simply grab our Allen wrench and do the final tightening on the feet. At this point, it's a great time to take a break, stand back, and admire your new Gravity Paramotors Defiant. This is one of those sections that you get excited to film. This is when I get to show you how to install the adaptive comfort system and the dynamic flight system. This bad boy right here is what Gravity Paramotors started with, is patented, and ready to rock and roll. The adaptive comfort system is where our arm pegs move in and out based on the comfort of the pilot. That is a guy that's 140 pounds and narrow as a twig, or a guy that's a little bit bigger, 230 pounds, such as me, that needs a little bit more room to breathe in the swing arms. The dynamic flight system is where the swing arm actually can move up to 4 inches total travel, 2 inches each way, to increase your weight shift and increase your maneuverability. We're going to go ahead and start with the small catch latch mechanism. Has an itty bitty M4 by 12 and a small CNC piece. And if you weren't tired yet, guess what? Add more Loctite. This piece on the front face, one has 2 small holes. One side's threaded, one side's not. The piece has a little nub. That's going to go into the non-threaded side. And then the small M4. This is a shallow thread screw. Definitely apply Loctite. Do not over tighten it, as it is a very small screw. The capture pin is pre-assembled, as if you thought the netting tensioner was bad, try and assemble one of these guys. That's going to lock the arm peg in place. Check out our YouTube video on just how strong that ACS system is. You're going to have the inner puck. There's going to be one side that's beveled, one side that has 3 single dots. The single dot means for the level 1. We have level 1 through level 4. Ask us about the level 5. The swing arm, we have just a little bit of prep to do before we slide the swing arm and the bearing that helps with that dynamic flight system. We're going to Lark's head the safety runner around the swing arm. And for the most aesthetically pleasing setup, you'll want to mirror image your right from your left so that both of the runners flow inward. You're going to place your bearing to whichever side doesn't have the smaller radius. Yes, the arms are universal between left and right, but you will just slide the bearing in. That puck rides on the bearing, not the swing arm. So that universal from left to right doesn't matter. Slide the swing arm onto the system. Your level 1 puck, the grooves and the cutouts face the outward of the swing arm. You're going to thread that on till it's good and tight and it sandwiches that bearing in the swing arm. Level 1 puck stands for 1 inch of travel out at the swing arm. We have a small dovetail piece that goes on the outside, slides down. We'll go from top to bottom. Then we have an M6 by 16 flathead. Again, this is one of those section, guys, that you don't want to forget the Loctite, as it is an aircraft. Thread that in, and you'll notice as the bolt bumps up against that dovetail piece, it shoves the dovetail into that swing arm of that outer level 1 puck. The ACS is completely assembled. One additional step, the safety strap. You pull your quick pin out enough to insert the safety strap into the void underneath where the swing arm attaches. You be sure that you catch both the swing arm itself and the safety strap, and then continue all the way in. Then you have 2 points of contact for both the swing arm and your harness. And these all swing arms are made from 70-75 grade aluminum, and you have the redundancy. We're going to repeat mirror image on the other side. Up next is the non-ACS version. It's great for the guys wanting to get into more economical paramotor, but if you want to upgrade to ACS, it's best to do it up front because there's quite a few parts that are going to be required to upgrade to take advantage of those patented systems from Gravity Paramotors. For the non-ACS version, since the Monster Plus torque's right, we throw more offset to the right. The larger arm peg, compared to this one, is a slightly longer, fixed offset, no ACS here. Goes in, it rotates. You have a specialty shoulder bolt. You have 4 of them included with your install. You have 4 of these shoulder bolts. This one goes in from the back side for the arm. Be sure to apply Loctite. As you can see, this unit's not completely assembled. Swing arm goes together in a very similar fashion. It already has that level 1 puck built in. The swing arm, instead of having the nice bearing for the DFS, you have a plastic insert that slips in and should be flush. Goes on to the arm peg next. The same level 1 puck as before is the ACS DFS. The same dovetail piece, universal between both sets. And then the M6 by 16. Again, all with Loctite. The safety strap gets secured with another shoulder bolt from the front at the lower position here. You repeat on the same on the other side, except you use a shorter arm peg block. Your final 5th M6 by 14 goes to attach your throttle cable. You have a cushion clamp. Even though our engineer had a fancy little slick device that utilized both of the attachment methods, sometimes the real world's a little different, and we think this is a little cleaner. Get it in the approximate location, that M6 by 14. Be sure to apply Loctite. And you can attach it to the upper or the lower, on the right or the left, depending on your install. Things to make note: ensure that you have ample play behind the frame / fuel tank for movement of the motor, and make sure that the rotation of your throttle is happy with what your install location is going to be. And of course, quick disclaimer, ensure that your kill throttle works before ever taking this product into the air. Finally, the last couple of pieces before we get to make some go-go juice flow. The other piece of fuel line and the primer bulb that we set aside earlier, we're going to need to attach to the nipple coming out of the fuel body and to the carburetor line here. You can go ahead and attach the little bit of excess line to the nipple. The fuel primer bulb, make note, there is an arrow direction. That arrow direction, that nipple that's on the arrow, needs to flow towards your carburetor, aka the line coming off your carburetor has to go to that side. The line that comes off of the fuel tank body needs to come to the other side. We do advise you to leave yourself some service loops. You can use additional blocks or zip ties and attach it to the back of the spoke blocks, or you can leave it hanging like I do. It's totally up to you. This is one of the things that you get to take your own discretion when building your paramotor. An auxiliary option is you can order additional 90-degree fittings to puncture into the fuel tank and run up a vent tube and have a blow style priming system instead of a primer bulb. Just let us know how we can help you customize your Gravity Paramotors Defiant. We're getting so close to burning that petrol fluid, I'm even getting excited. We're going to install the rest of our spokes into the other 3 locations. If you did go ahead and pre-install your pulley, make sure that one goes in the top dead center one. Tubing. Again, some of them might be a little bit snug if it's the first time they've been put together. See if I can do this with this bad boy several feet in the air. When you come down to the final piece, you will have to apply some outward pressure to bow your line in to get it to lock down in position. From here, we're ready to go ahead and start doing our netting. You're going to receive a couple items: your netting, a large spool, and a small spool line. So first, we're going to jump right in. We're going to do some initial line prep that's going to make stringing the net a whole lot easier. We'll go ahead and practice on our short, extra long scrap piece here. You are going to want to use something like a disposable razor blade, as this line is very durable and it's going to dull whatever you use. So first, we're going to start by pulling some of the sheathing back and cutting away some of the inner core. What this does, it takes away the nylon core, and as you can see, she is extremely rigid. Even with a razor blade, it's having a tough time cutting it. You're going to pull the sheathing back over so that you have a dimple. You can use anything from a lighter all the way up to a hot knife, and a hot knife is going to be your best cut to give you a nice sealed end. Even a small torch would also work. In this case, we have to wait for our hot knife to bring up in temperature, and we're going to trim it between 1/4 inch and 1/2 inch from where the inner core sheathing stops. This is going to allow it to not bunch up and fray as we're fishing it through the eyelets to attach the netting. That in turn gives us a nice little finished end. So we're going to go ahead and do that on all 4 ends, on both the small cord and the long cord. Now that we've gotten all of our 4 ends prepped on our line, we're going to move on prepping the net. So the net has 2 key points that we need to go through and identify. Point 1 is going to be center of where the net is. Point 2 is going to be the orientation of what we like to string for the left and the right side. So after you cut the holding string from your net, you look at the bottom corners of the black, and you're going to find one side looks quite a bit different than the other. And we'll pull those apart and show you here. So on that, one side ends with a knot and 2 square pieces, as such. The other side ends with a nice final loop. So the square piece is actually going to be the left side of our net as we're staring at the paramotor, or the right as the paramotor flies. The other side will be the opposite. Next thing we need to identify is where's the center of this big net. You're going to start either end, and you're going to go ahead and count to 24 on complete loops for where the string was holding it. So the 24th loop, that next knot is the center of the netting. All right, so now that we've identified the center of our net with 24 loops on both sides of the knot, as well as that knot in the center with the square pieces on the ends, that will be the left side as you face your paramotor, you'll want to hang the knot directly on the top spoke. From there, we're going to start lining the net both to the left and to the right. We'll take our long cord that we terminated the ends earlier. We're only going to work with one side for now. And you'll notice the line has a memory in it, and that is how it was tied. For the best aesthetically pleasing net, you will want to go under so that it lays in the manner that is the most aesthetically pleasing. You'll start off with one loop, and then the piece of the tubing, and then you'll go 2 loops to the next, 2 loops to the next, and so on. And you'll do this all the way down to the midpoint as it comes around the paramotor. You'll take the other end, and the reason we only did one to start is because the second between that next attaching point is going to get from this line this way, and it's going to go over the first piece of net, under the next, and then in. It's going to be 1, 2, 1, 2, and you will continue that all the way down to the midsection, and it does help to raise it on a bench after that. So after you get the top half of both sides done, get it in a more appropriate working manner, and you're going to continue that same 2 loops and then a rivet, and you're going to continue that down to the last one, and then it changes just slightly. Continue down, 2 loops, 2 loops, and then after this last piece of riveted, you're actually only going to do 1 loop, and that's because it doesn't go the same distance required before. So 1 loop, and you're going to pull all but about 12 to 24 inches of your slack out to this side, as it's going to also be the leader that continues up the inside diameter of the netting. Here's where a little bit of trial and error comes in, is you have side loops that you'll need to connect onto. So you'll take the end of your line, hold your netting approximately up, and you can kind of see the loops that you're going to want to catch. Then, when you get to the last loop, that's right here, that's when you take one of the silver pieces. There's 2 of these included. This is a little tricky by yourself. A second set of hands does help. But what we want to do is we want the string to pass through this loop twice. And how we do it is we grab it on opposing sides, twist them up opposing. You will fish your line through first. Put your pulley-less pulley on with the lesser smooth side onto the line, and then continue on through the netting. Pull all your slack onto. Quick tip, and that is to tie your short piece of line to that pulley-less pulley and route it through your tensioner to help keep your net in the approximate orientation it will need to remain in. Now we're going to go ahead and fish the line through the inner diameter, and again making note of how the netting is already laying for the most aesthetically pleasing finished net possible. You'll go ahead and continue this all the way around the inner diameter to the left side as you face it of your paramotor. Okay, once you finish routing the line across the inner portion, you'll come to that starting point for the 2 squares and the knot. You'll go ahead and come out one of them. This is where you go ahead and use your second pulley-less pulley, again the lesser smooth side onto the line. And you'll do the same thing as you did on the other side except reverse, is that you're going to go ahead and try and work the line on these lower squares first. And you kind of have to hold it up and identify what's the lowest piece that you can grab onto. At that point, you now have the two lines where they meet. From here, we're going to have to do a little bit of work on the backside to give us a baseline for where we should tie our line next. Now that we have most of the netting routed, we're going to want to take that short piece of line. We're going to want to loop it around the pulley-less pulley. Same for the other side, and come into the netting tensioner. The main string that goes between the 2 points is behind the tightening mechanism. Both ends go into the tightening mechanism. You can barely place it through and do a twist or two to kind of be a placeholder. You're going to want to pull the string tight until you limit the size of this small area right here. You want it to look approximately like this or even a touch smaller. For testing purposes, you can go ahead and do a square knot. Pull tight and make sure now you can add tension to your net and see where everything lies. You're going to want to pay close attention to all turn points between each one of the rivets and make sure that all the way around your net actually has a smooth edge and you don't have excess material anywhere. The opposing side may need slight attention to shift around. From here, we want to finalize what distance we're happy with. This is what I would call a little bit too long of a net, so we'll want to reduce tension, or too long of a main line for the net. And we're going to want to tighten that up, or make the line shorter. Then go ahead and retension. Feel free to grab an Allen wrench at this point and put real additional tension on your net. Once you're happy with the space sizing here, I would call this the maximum that I would want to allow. Make sure that tension all the way around the net's good. Now we're going to mark this is where we want our line length to be terminated. So now that we have all the basic netting in place, we went ahead and put quite a bit of tension on the netting itself. Here we have our original square knot that we started with. You have many options, but we're going to go ahead and finalize the square knot with an overhand safety knot at each end. And you're simply going to put a locking overhand knot at each end to help prevent the line from slipping. And you're going to trim the ends similar as before to an appropriate length that you're okay with. And you will want to be sure to burn the ends as before to prevent fraying. You have several options. You could use other knots such as a double fisherman's knot, or as well as a through knot. So with that, you can use the knot of your choosing. Lots of YouTube videos show you how to tie that individual knot. You do want to make sure that each and every piece of your tubing is completely closed and that there's no gaps. And with this new netting tensioner from Gravity Defiant, you are able to put an excessive amount of tension on your net to the point of being able to strum your net. If you have any questions, please let us know. This is a good basic overview. If you have any ways that we can improve it, please let us know. You might have noticed in the last scene, our netting magically disappeared and our background changed. We're constantly making improvements to not only our products, but also our film studio so that we can bring you a better instruction and a better guide to the products that are going to help keep you in the air. So we're going to be mounting the Apco split leg harness. It is the lightest and most cost-effective harness option available. We also have the Apco SLT. We're currently testing the Dudek power seat, should be available by December of 2020, as well as a custom-made lightweight harness in that same variant. We also have limited quantities available remaining of the Gravity Paramotors custom SUP-Air harness that we hope to bring back to the market 2021 as production availability does free up with suppliers. One critical factor that must be on any harness to mount onto the Gravity Paramotors Defiant or Defy is a small loop to have our proprietary harness attachment to the frame. And that allows our quick release bar to actually mount to the harness in a safe manner. On all harnesses, you will have extra webbing that it is up to you to either remove, shorten, or secure on your individual method. If you cut them off, it'll make it great for your Gravity Paramotors, but it will make it unable to mount to any other harness in the future. Totally up to you on how you want to deal with that. Let's go ahead and take the first step to mounting the harness bar. You actually, on this particular harness, you have 2 available loops to mount this bar into. If you are taller, you're definitely going to want to use the upper. If you're a little shorter, you may want to use the lower. It may take some trial and error to see which one fits best for you. It is a little tight to get in the first time. You have to push the bar in, pass through, come back to pick up the second one. As such, you have to pull the harness outward to catch the second ear. It should look something like that. So you're going to want to identify your 2 M8 by 60 button heads, as well as the 4 small cylinder pieces. One's going to be plastic, a bit thicker. One's aluminum, has a thinner flange, but threads all the way through. First, you're going to place the M8 button head through the face of the harness bar. You're going to apply the plastic next as it tapers towards the paramotor. Same on the other side. Then, at the top location of the harness, or the paramotor, slide it into position in the back plate. You can hold this in position and you can start your metal threaded from the back, just like a nut. It should spin on freely. If it requires a wrench until final tightening, it is potentially cross-threaded, and check. Once we get both sides started, to loosely hold our paramotor in location, doing it blind for the shot. You can go ahead and use your Allen wrench to make life a little easier. You can hold the back side, the piece that it's threaded into. All you're trying to do is hold it in position so the bolt threads in. And you'll go ahead and tighten down both sides. If you intend on removing your harness quite frequently, you may not want to use Loctite. There is a lot of thread. You'll definitely notice as the bolts come out. If you don't plan on disassembling your paramotor much, definitely would advise some purple or greater Vibratite thread locker. Attaching the ground support straps, you'll have one. The vertical one will need to go to the lower attachment point. Horizontal one will go to the upper attachment point. So we are going to use 4 tri-glides, and you weave it on one way. Come down to your ground support buckle. Through the buckle, back onto itself. Move the tri-glide down. Move it back to the tri-glide, and then back over on itself one last time to be secure. Do note that any of Gravity Paramotors' custom harnesses that uses the ground supporting strap through the harness, you will need to keep this tri-glide and this buckle as tight, as close together as possible, otherwise it can limit your seat movement. Also, several custom harnesses also come with an excessively long ground supporting strap to allow you to mount it to additional harnesses. You will need to remove material on some units. This is something that an instructor or your dealer can help you size your Gravity Paramotors exactly how you want it. Up on the upper, we're just going to repeat the process And if you noticed, I changed, is that you want the webbing to be in the center and the outer parts of the metal to show, to have proper, most aesthetically pleasing install. It will work both directions. And then back through once more for safety. And in this case, you would want to undo that and add just a little bit more material back through the tri-glide. Then just repeat on the other side. Let's go ahead and get the last couple pieces attached so we can actually go fly. For the outer arm attachment, you have these witchered shackles, and you also have a heavy-duty key ring. This is extremely important for safety. You're going to identify the outer harness attachment point, and if you rotate it as if you're wearing it, it should be centered forward, such as that. I prefer the nut side of this witchered shackle to be to the outside, as sometimes your rib cage can find it. You will put on the key ring safety. Always start out in the outermost hole. The other two holes are really for just absolutely fine-tuning your offset and hang angle. Feel free to experiment as you get some time under it. But for default installations, always go to the outermost hole in the arm. You will fish the key ring through the eyelet of the witchered shackle, and that is to ensure that it cannot back out, and is something that should be on every single pre-flight as a check. The runners are for our carabiner attachment point. You will want to either, in your own hanging simulator or with an instructor or your dealer, figure out what hold position is going to work best for you. On some individual harnesses, or you can get additional safety straps, such as this one, that are already either made or can be Latch-headed onto your unit. You can run that through your runner as well. Makes it a little tight, but still doable. And we always prefer the gates to the gut. The Defiant comes standard with aluminum carabiners, and steel carabiners is an upgradable option. And with that, our swing arm's complete. We're going to do it on the other side. On to one of the last steps before you fly your Gravity Paramotors Defiant. Pull out your starter rope until you get to the white line marker. Make a loose overhand knot to prevent your line from accidentally coiling up into your flash starter. You'll remove the knot that holds on the starter handle. With the line removed from the starter handle and our safety nut to keep our line from retracting back into the flash starter, we'll route the line through the pulley, with ensuring that the plastic insert is properly seated into the starter handle. From the outside grommet side in, you'll route the line into the starter handle. We're going to put a quick safety knot so that as we remove the knot on the back side, we don't accidentally release the line to go back into the flash starter. Don't skip that step, guys, because when it goes back into the flash starter, it is not a fun day. So you'll locate that white mark on the starter line again, right here, and that mark needs to be at the very start of the flash starter at this location. So right here is where our starter line needs to be. You'll make a mark note of it. You'll want to bring your starter rope up to that same position. Be sure to check that white line mark, and you can go ahead and make a double overhand knot at the position you like. Leave an amount of excess that you deem necessary and trim the rest. And with all that, it is now ready for its first pre-flight before its main voyage. Everyone at Gravity Paramotors wants to thank you for either being a Gravity Paramotors customer or looking at becoming a Gravity Paramotors customer. If after this video you have any questions whatsoever, contact your local dealer. Thank you and fly safe.